Welcome to this session about building your data platform on Airflow and GCP. My name is Natalie Godec. I'm a platform engineer at Babylon Health. We are a London-based digital healthcare company. My job is pretty much described as a DevOps engineer. I focus on infrastructure on both AWS and GCP. And I also really like photography, so you can find me on Instagram on that tag. I would like to first start with talking a bit about our mission. You see, I live in London, and the national healthcare system is really good. It is free, it is accessible to everyone, and everyone who needs healthcare and needs help for any kind of medical problem can get it. However, you can have to sometimes wait up to 6 weeks to see a GP, un médecin généraliste, known in here. I don't know about you, but I think in 6 weeks, I'm going to either be dead or healthy, neither of which requires seeing a doctor. So, yeah. And when I lived in Switzerland, you know all the story, I could see a doctor the next day, but it would cost me 180 francs on top of the 400 francs mandatory health insurance. Not the best scenario either. And in the meantime, in countries like Rwanda, most of the people simply cannot see a doctor when they want to. They live in places where healthcare is not accessible, and they cannot afford to go to a nearest town that has a doctor or a healthcare clinic. So that's why at Babylon, we're on a mission to bring accessible and affordable health care into the hands of every single person on Earth. And I mean into the hands. Raise your hand if you have your phone on you right now. All right, pretty much everyone. And it's the case everywhere on the planet. Most of people nowadays have a phone, and even in places in Africa where the electricity is only available to like 15% of the population, phones are something that 80% of the population have, which makes the most profitable business in some of the cities a phone charging station. The way we go about delivering our mission is by developing applications and services that deliver you digital healthcare. We develop AI, something that we called Babylon Brain. It is a medical AI that you can talk to through a symptoms checker, and you can tell the chat how you feel and what maybe is bothering you, and it will go into triaging billions of different symptoms and combinations of symptoms and asking you questions and to determine the probability of you having a certain condition. And maybe you just need to rest. But maybe you need to see a doctor, which you can also do through the app. From the comfort of your bed, you stay home, you cuddle your cat, and you speak to the doctor via video or a phone call. No more going to the clinics, no more taking your germs with you, taking public transport. We're in Switzerland, driving while you feel sick. You can do it from your phone. And we also believe that healthcare doesn't start when you feel sick. In fact, it's a little bit too late when you are sick. So we develop your monitoring tools and your health check tools, where you can monitor your habits and how you feel physically and mentally in order to assess how your health is right now or is going to be. We want to be a global company. We want to deliver healthcare to every person on Earth. So currently we're deployed in the UK, United States, Canada, Rwanda, Southeast Asia, and just launched in Saudi Arabia. And you can imagine that as a healthcare company, we deal with a lot of data. And as an AI-based, AI-driven healthcare company, we deal with even more data. And it's the same truth for everyone, and it's becoming more and more prominent that we will have to deal with data all the time. And the success of your business depends on how well you can deal with real-time data and how well you can do data-driven decisions. And this data can come from different sources. It can be your event logs, your microservices events. It can be something from app and web analytics if you want to make sense of how your clients react to your website, to your application, if you have an application, how they communicate with each other, how they click through the things. Or you can also obtain publicly available data sets, such as synthetic data for healthcare or statistical data that things like companies like Gartner or Bloomberg would publish. And really anything that is generated in the modern world can generate data, which makes your executives go, give me that data. In fact, give me it yesterday. Why do we not have it yet? And to give them what they want, let's first have a look at what we want to achieve, what we want to do. What we want to do is we want to collect and store data securely. We want to enable analysis and research on that data to allow us to produce insights and make data-driven decisions. So the goal here really is to enable our teams to access, analyze, and research on provided data in a safe, secure, and auditable manner. We are a healthcare company, again, and our application is classified as a medical device. So we are very heavily audited and heavily regulated. And all of you who are maybe in financial services or in banking will know the story. You have to really comply with all of the rules and regulations that are out there. And for data, it's very, very important. If we look at how data management and data analysis was enabled previously, most of you will probably be familiar with this setup. You have Kafka for streaming, NiFi for ingestion, and then Hadoop and Hive for data warehousing, which produces company chats like this. Hive is slow, the queries are bad. And then there's people like me that screenshot those chats and go to conferences with them. But what are really the challenges? Why do people react like this to this product? Well, first of all, it's all infrastructure that you have to manage. You have to have a team of engineers that goes on and develops, deploys this infrastructure, that scales it, plans on how it's going to be, how the load's going to grow. What if we have a disaster and something happens and we need to rebuild, and so on. It's all the skills, the additional skills and additional people that you have to have on your teams. And speaking of skills, querying data in these tools is also not that evident. So it's special data analysis skills that you have to have. It's difficult to scale them because it's your own infrastructure. And it's kind of difficult to give granular access control to specific data sets. And to iterate on that a bit more, this is how a data researcher, a data analyst would go by at Babylon just a few months ago, when they needed some data. They would go to the data engineering team and say, I'd like this data set. And the data engineering team would go, give me a few months. They would need to go and find the data that is requested, figure out where to put it, how to make a data set out of it, how to give access to that data set. What are the tools that the analyzer, the researcher will need to work on the data that they've been provided? And at the same time, there's a whole legal process that needs to go because we're regulated, where the legal and compliance teams would need to go and analyze whether that person is even allowed to use the data and see it. So it would be very frustrating and take very long time. And that's only one researcher, and think about more researchers, and it all goes the same story again and again. So how can we give our teams access to data that they need when they need it, safely and securely? Enter Google BigQuery. BigQuery is Google's data warehousing tool. It is completely managed by Google. It is serverless. It scales automatically. Behind you have compute and storage that are separated, so you can scale your storage independently from your compute. And you don't pay for storing the data. You only pay for querying it, which makes it very, very cost efficient. It's also a REST API, so really easy to integrate with everything. And it's based on SQL, so anyone who knows how to write select name ID from table can go and analyze data in BigQuery. Really good. And the way it is structured, you have GCP projects, which are your kind of workspaces, your little bubbles where you group your resources in. Kind of similar to Amazon's accounts, but also you can create many, many, many of them and do a very granular segregation of access and resources. In the projects, you put in datasets. Datasets can be located in a region, which is really important for businesses that care about where their data is stored. Finance and healthcare are very prominent examples of that. And then for each data set, you create tables, you define schemas for those tables, and you put data in it. And then, once your data is in BigQuery, you can do whatever you want with it. You can query it through BigQuery, you can transform it through Cloud Composer, you can plug in visualization tools such as Looker and Tableau and whatever your BI solution of choice is. You can run ML pipelines and data modeling and do your AI research on top of that data using pretty much the tools of your choice. Google has their own ML suite, or you can run Jupyter Notebooks, whatever. It's so developers and data engineers are really happy about that. And this is what we've done at Babylon. Our events are in Kafka. All of our microservices are on Amazon EKS, so the Amazon Managed Kubernetes Service. Kafka is also there. All the events go to Kafka. Then we have a few more microservices that subscribe to certain topics and then write those topics into BigQuery. So at that point, the data is transferred into Google through a secured encrypted VPN tunnel. Then we write it either into BigQuery or into storage, because BigQuery can also query storage, which is very handy if you just want to dump all your data into storage, into a bucket, and forget about it. Then we do transformation, which if any of you are data engineers, you will know that there is ETL and ELT, extract, transform, load. They're kind of the more traditional way of doing it. And BigQuery enables you to do ELT, extract, load, then transform. And you use Cloud Composer and Airflow, and I'll speak about it in a moment in more detail. You can query directly using BigQuery and SQL queries. You can visualize. We use Tableau and Looker for visualization. We're evaluating which tool is more fit for what we want to do. And we run machine learning pipelines, because we are an AI-driven company, so we need to do a lot of data analysis, data modeling, machine learning, natural language processing on top of the data that we have. Our ML pipelines run on Kubeflow in a tool called Air, which is an AI research platform developed in Babylon. If you'd like to learn a bit more about how we run ML pipelines on top of Kubeflow, you can search for talks from last year's reInvent and KubeCon. My colleague Jeremy Vallée did some talks about his work on that in that space. Cloud Composer, that I mentioned a few times, is Google's managed Airflow. For those of you who don't know what Airflow is, it is an open source product for running pipelines. It is a scheduler, in fact, and Cloud Composer is just Google managed. You deploy a Cloud Composer environment, and you don't have to worry about how it's managed at all. You have your logging, your monitoring, all embedded inside. Google chose to build their scheduler on top of Airflow because Airflow is a really well community-focused and community-driven tool that is actively developed. When you deploy a Cloud Composer environment, you have a Kubernetes cluster that is deployed for you. You just define which machines you want, which types you want. And you also have some storage, because that's where you will store your code for the pipelines. They're called DAGs, Direct Acyclic Graphs. And you also have a database, a web server, and a scheduler that all form Cloud Composer and all help you to run your data analysis transformation pipelines automatically, and you don't never have to worry about what is going on behind. When you run transformations on Cloud Composer, you then run your output data, you put it in BigQuery. So you have your raw kind of data that is not structured in BigQuery, and you also have your transformed data in the same place. And you also can store your DAGs, your pipelines, in Git, so that enables you to do version control and to control really what is going on with your data and do all of the CI/CD goodness around that. A bit to explain how DAGs work. So you have a pipeline that consists of different steps. Each step can do whatever you want it to do. It's usually a Python script, so literally whatever you want to do. And each step is called an operator. It can be a bash script, and it can be Python code, it can be an SQL query. And the idea behind DAGs is that you have an entry point and an exit point. And then from the entry point, you have branching, and you have different things that happen to your data where you define the analysis, the transformations that you need in order to form the data set that maybe your data analysts want, and to output it and put it in BigQuery. And here on the right, I never know which one is left, which one is right. On your right, you see a sample structure of how we structure DAGs at Babylon. We have the scripts themselves, we have some modules and plugins that we want to have running, and we also define schemas for the data sets, because each DAG has a goal of writing and structuring some sort of data set, so we define those schemas in the DAGs as well. And all of it is managed automatically. We have pipelines for everyone, and you can use pipelines of your choice to deploy all of your infrastructure. We use EKS, like I said, for microservices. We have a tool that is developed internally called ChipCat that manages all of the deployments in different environments. Whatever you use for your Kubernetes deployments or for your services deployments can be used. Then for BigQuery and storage, we create the buckets and we create the data sets using Terraform. And we do that in order to define which region the data is going to reside. By default, BigQuery will probably choose US region. But we can define this way, we can define exactly where our data will be stored, which is a really big advantage of using BigQuery for your data management. Then for transformations, we deploy Cloud Composer environments using BigQuery as well, or using Terraform as well. Tableau and Looker are also deployed using Terraform. And then ML pipelines, this is the Air platform, this is Kubeflow, also running on Kubernetes clusters. The way we deploy the infrastructure itself. When your data engineers come to you and say, I want BigQuery, or maybe you're a data engineer and you will go to your infrastructure team tomorrow and say, oh, I heard this amazing talk, I really want to use BigQuery now. What does that actually mean in terms of infrastructure? You need several components, in fact. You need to create the GCP projects as your workspaces. You need to deploy some storage buckets and a network if you want to run Cloud Composer. You need to deploy the Cloud Composer environment and some BigQuery datasets to define where your data is stored. On top of that, you want to secure this whole thing. So you will define your IAM roles, your user accesses, your service accounts that will run and have access to specific datasets. And you also define something called VPC service controls that I will explain in a little bit more detail later, but you can think about it as a firewall on steroids. It controls the network accesses, the user accesses, and segregates resources, and really secures your APIs inside this perimeter. In fact, it even changes the DNS address of BigQuery. So when the requests go to the API, they don't go to the public API. They go to a specific DNS address. And if you want intra-cloud connectivity, you create VPN tunnels for the data to be transferred through securely. And we do that all with Terraform, because why not? We use a structure of components and modules, which is a very handy way of compartmentalizing your code and making it more portable and more usable. So for modules, we define the little groups of resources that need to be deployed. Like for Composer, you will need the Cloud Composer environment, which is a resource, and you will need some service accounts for Composer agents to run on and to access BigQuery with. And then in components, we deploy, in fact, all the business logic and all of the addresses, all of the namings that will go into these different data projects in GCP. And it's time for a demo, and it's really good to have my laptop right here. So, no, I'm good. So, let's go here. I am in my Terraform directory. I guess it's big enough. I do a clear. So we see that there are components and modules. And if we look into components, we will see what I showed in the slide just before. We have a BigQuery, we have Cloud Composer, networking, buckets, project, service accounts. If I look into components GCP projects, into Terraform, I think it's main, yep. This is a definition of a project. We use modules for defining GCP projects, because for a project we also want to deploy not just the project itself, we want to create a bucket for Terraform state to be stored in, and we want to turn on some APIs, like the storage API, the BigQuery API, and so on. So we define that. You can see that in services right here, I say turn me on BigQuery and Composer, and the module will take care of that. So I've already deployed that. And if I go back here, here's my project. This is the Google Cloud Console, in case you haven't seen it. This is where you can browse and see all of your resources. I've deployed a project called Demo Project for DevopsDays Geneva, and I have turned on BigQuery API. And in fact, if we go into BigQuery here, we will see that I have deployed a test dataset and have put some data in it. The way I did it is also with Terraform. So it's just a simple resource. You give it a name, you give it a region, and you give some access controls. Here you see that I say that the Cloud Composer service account has the writer access into this project, into this dataset. And why not deploy another one? Let's do another public health dataset. I will just add it into Terraform, and you'll see how easy it is to deploy resources. So save, go back to my console, and I will do kube apply, Terraform apply. And no, I will not. We'll go into components, BigQuery, Terraform, and we do Terraform apply. So you just saw me adding this second dataset here. And if I, in fact, click apply, it will plan, and it will show me that there effectively is one resource to add. So let's click yes, it takes just a second. And then if we go and refresh in the console, we will see that there is a second dataset deployed. There's two now. So it really took me half a second to add another resource. And when you do your pipelines and when you do your whatever your CI/CD tool of choice is, it's really easy to automate it, and it's really easy to give it to your developers and to your data engineers and say, just submit me APR, and we will deploy it. And they can submit you APR, and then it's them who deal with the resource management of their own stuff. Also in the console, we can see that there is a composer. And so when I was speaking about composer environments, if this loads, we see that there is indeed a composer environment that I deployed just before. If we have a look at that, here's all of your configuration that is showed here. You have your logs, your details, your bucket into which you will submit your code, and you also have the Airflow Web UI, which is a tool that data engineers really like using to monitor their data flows and their data pipelines. And you also have a direct link to logs. Google's way of managing logs is really interesting. It's automatically enabled, and it also has automatically audit logs with all of the accesses and all of the requests that go through, which is a big relief for any kind of infrastructure team, because we don't have to worry about that anymore. If we have auditors that come in, we can just show them the logs that are already there automatically. Now, if I go to Airflow Web UI, since we mentioned that for your data transformation, you can use Airflow. And you can see that there is just one DAG right now. It's Airflow monitoring. And that one just monitors the cluster. It pings, it does just one little operator and to see if it succeeds or not, to see if the cluster is healthy or not. So that is embedded as well. But if you wanted to do some transformation pipeline, let me show you how you can do that. This is an example of a DAG. Like I said, it's a Python script. You have all of your Airflow operators that you can import for all of your kind of needs. And then we define different operators, so Python operator or BigQuery operator. And these will be the steps that the pipeline will execute. So for me, I have hello, I have BQ health data query. I will query publicly available health data. I mentioned at the beginning of my presentation that you can have publicly accessible data sets. And there's loads of them, and Google provides some of them automatically. So you can browse them in the console. Like if we go back to BigQuery actually, and you do add data, and you do explore public datasets, and you will see that there's loads of categories and loads of datasets. And when you click on one of them, then you can browse the companies and the subjects of the datasets, and it's really good for all of your kind of market research, statistical analysis, your ML and NLP data modelings, to train your models on the publicly available data, because that will be your non-PII. There will be no personal information in there. A lot of the data will be randomly generated just to reflect the structure that you would like to see. And then if you even click on some of them, then you can even see some examples of how to use that data set, which is really handy. So I had a look at one of them, which was about kind of public health but synthetically generated data. I have put it into my test data, into synthetic public data table. And so if I go back to the DAG, that is in fact what I am going to query. I'm going to query and count the number of people that ordered a specific product from this dataset. And I will write it into a new table, hopefully, because the demo gods sometimes are not on our side. So let's import that file. So I have it right here, and I will use the gcloud CLI to import it. Da-da-da-da-ding. Import. gcloud composer environments, storage DAGs import. You can save it somewhere and not forget it, not think about it again. You specify which composer environment you upload it to. You specify the location, because that's important, and you give it the source. So we'll do that. And while it's importing, because that takes a little bit of time, maybe like half a minute, I'll go back to the DAG itself and explain a bit more how the scheduling part works. If you look at the line right here, like at the end, you can see it, you see that the three steps, the three operators that I defined before, I just give them a sequence. And that will mean that the health data query step will have to be executed after the first step succeeded, and then the goodbye step will be executed after the query succeeded. So this is a really simple example, right? This is just 3 steps: hello, query, goodbye. You can define a very, very complex structures, and it's a whole new job. People that write these DAGs and they then transform the data sets into something new. They're called data engineers in our case. And to be honest, I'm an infrastructure engineer, so this is pretty much as far as I can go in writing DAGs. So let's go back to Airflow and see if it has loaded the DAG that we just said. Yep, it did. So it shows its name. This is the schedule, so I set it to run every 60 minutes. These are your recent tasks. You can go in and see the logs and see what happened. Like if I have a look here, task ID, it gives you loads of information, which is really handy. And remember that before Composer and before GCP, Airflow had to be managed manually. So you had to deploy it somewhere, you had to deploy the scheduler somewhere, you had to have the UI managed on your own. So that's all of your infrastructure teams that need to deal with that. Now it's deployed automatically as long as you create a Composer environment. So like for me, it's really handy because my data engineers have what they want, they're happy, I'm happy. You can also browse logs, so they really like it, the data engineers really like it, you can see everything that happened. Very good. And now if we go back to BigQuery, and hopefully there's a table that has appeared. So we go into the datasets. Public health data is the dataset that we deployed 2 minutes back, and now there is a new table in there. And that was deployed, that was created and populated by Airflow. You can preview, you can see that there are some values in it. So your transformation, you have the existing dataset, the existing table, with all of the different things, all of the different data, and that can be your event logs, that can be your microservices output, that can be your web usage data. I know that we use for app and web usage, we use Google Analytics, so we've plugged that into BigQuery, and our analysts and insights people can now use the visualization tools that we have plugged into everything else to visualize the app usage as well. So it's pretty easy, right? You deploy it, everything is good, everyone manages everything. Now, if we go back to the presentation, you've deployed it all, you put all of your data in it, now you need to secure that stuff, right? Because if you're like us and you deal with data that is potentially sensitive, even if it's anonymized completely, even if it's like synthetically generated, not everyone has access to the same kind of data sets. So what we can do with GCP, you have your access controls on the level of the projects themselves or on the level of the data sets and storage buckets. When you have a user that comes to you and says, I want to access dataset 1, you can, if you give them access on the project level, they will have the ability to read, or whatever the access controls you gave them, all of the resources inside that project, which is the model that we chose to do. We chose to segregate user access by groups. We use Okta, which is an SSO provider. So each group has access to a certain number of projects to which they are allowed to see and do and work, and I'll explain the structure in like 2 slides. So you declare your IAM roles for each of your groups, or you can also do ACLs, access control lists on specific resources. Like when I did the demo, I showed that each dataset had the access control on them for Composer user, the service account. So that's your ACLs. That means that that user will only be able to access that particular dataset, or storage bucket, or compute instance, because it's a cloud provider. GCP is a cloud provider, so everything that you can do in Amazon, you can do in GCP, and more, in both cases. And the structure that we have given to our data projects is we have all of the prod data transformed, anonymized, and everything going into a separate project. And you have the datasets there, you have Cloud Composer there, the transformation happens in that project. But only service accounts have access to write in there, which gives the services that listen to Kafka and to Cloud Composer the access to transform the data. However, the users can only read, and even more, they have their own projects. Insights, analysts, researchers, they have their own workspace in which they can create in there, so they can read the data from the prod project, load it into their own workspace, transform the way they need, and create new tables. Which means that your main data is untouched, is immutable. The users that want to work with the data cannot do anything with it. They can just read. And it's a public API, so not only user access needs to be controlled. What are VPC service controls that I mentioned before? I said that it's like a firewall. You define the rules for accessing a group of resources. You choose which APIs you want to block. We lock BigQuery. You can lock storage and compute and stuff like that. And you define the list of the projects that you want to secure. For instance, your main data projects, you want to secure them, you put them inside a service perimeter. And then you define which service accounts, which IP addresses, which other GCP projects can access the APIs that you have secured. Anything else cannot have access. Even when we had like some issues with linking the Google's analytics tools, into BigQuery, we needed some help from Google employees, so we had to explicitly give them access into our security perimeters, because even they couldn't access it. And it's also defined in Terraform, so all nicely automatically deployed. And in fact, it is really automatically deployed. The job in Jenkins launches as soon as the PR is merged. And then it does some logic on, are you deleting anything? If you are, then no, let's not deploy that. And the way we segregated the data readers and the main data applies to the service controls as well. Because we have a trusted research perimeter and a main data perimeter, and there is a bridge between them for accessing. So your main data is really secure. Nothing can access it except those specific tools and those specific services that you allow it to. And I would like to touch a little bit on the workflow as well, because this is a DevOps conference, and something that we noticed was when we started working with our data teams, we did not have a common language. And we've been talking in the DevOps community about how developers and operations need to talk more, how teams need to build bridges between them, how we need to break down barriers, how we need to destroy the silos. And it's been doing pretty good. We've done a lot of improvement, but not really in the data space. The data space is still quite segregated and quite separated. And so when we started talking, we wouldn't understand each other. Our data engineers would come to us and say, hey, I'm testing this pipeline I'm building for the data. Can I have prod access? And we were like, no, of course not, it's prod. But in fact, they are data engineers, so they do need access to prod data in order to build correct pipelines that will run on prod data. It would be really good to have the same structure of maybe synthetically generated data in pre-prod and in dev, but it's far from reality. So we needed to kind of talk to each other and sit down and work together in order to build the comprehension between us and build the product that would work for everyone. Because we want to restrict everything, right? We want security, we want infrastructure to be untouched, but they want to work really fast and deploy their things and do their data models. So collaboration was really, really important for us. And like I said at the beginning, we are entering the world of Internet of Things. We're entering the world of real-time data processing, and more people are talking about how important it is to build flexible, agile data platforms. Because in 5-10 years, you're not going to be able to succeed, you're not going to be able to move fast enough if you don't have a flexible data platform. So hopefully everything that I spoke about today will give you a little bit of an insight on how you can use the cloud tools and all of the providers that we have today to build a platform for your data engineers and your analysts. And you can use the immense quantities of insights that you already have in your estate, but you don't even know they are there. Thank you very much. You can get in touch in these links. I don't have Twitter, Babylon has Twitter, so please subscribe. And we have a blog where we write about all the awesome things that we develop in the space of AI, machine learning, healthcare, infrastructure, and all of that. Thank you. We have some time for questions. I can answer questions in English, mais également en français.
Thank you very much, Natalie. Despite the initial beginning, there was a bit tight, great talk. And we have a few minutes for questions if you want. Any questions for Natalia? Yes, just a second.
Excellent talk, thank you very much. I'm really glad to see that Babylon is actually using really modern stuff. Hopefully you will update your slides a little bit more with some more specific Terraform code.
Terraform code that you, yes.
But it was good enough, thank you very much. At the beginning of your talk, you had a slide where you showed that you use Elastic Kubernetes Service by AWS. And the rest of the talk was about how good and how powerful Google is.
Yep.
Why there is AWS at all? Like historically, can you tell what was, yeah, exactly this one. Do you use EKS, for what reason? because everything the rest is on Google, right?
So,
and Google actually has its own EKS.
Yes, they do. Historically, we are an Amazon box. We deploy everything, all of the services, all of the infrastructure on Amazon. It's Google that came later, because when we started thinking about a data platform and started evaluating the offerings from various providers, we needed something really quickly and really easy for our data engineers and insights people to use. So we chose Google's offering because BigQuery is really easy. We could deploy it really quickly. There's no learning curve for our data analysts because they already were using Airflow and they already had all of their DAGs, so they could just migrate really quickly to Google.
Just a small question, DAG, when you mentioned DAG, what is it?
Direct acyclic graph. It's a mathematical term originally, but it just describes a pipeline that is written in Python and that goes from one point and goes into branching and different tasks that are executed in parallel.
Yeah, thank you very much.
Thank you. Any other questions? Otherwise, yes.
Bonjour, Joseph Lorieux. J'ai en fait la même question, mais de l'autre côté, c'est-à-dire pourquoi ne pas avoir considéré Redshift ou un équivalent côté Amazon, puisque vous y étiez déjà. C'est-à-dire, c'est quoi les key features de BigQuery qu'on fait basculer le choix vers Google?
Est-ce que ça vous dérange si je réponds en anglais, comme ça tout le monde comprenne? So the question was, why did we choose BigQuery versus Redshift? In Redshift, there is a little bit more infrastructure management that you have to do. The querying part of the ease of using SQL is pretty much the same, but the flexibility of BigQuery is higher. You don't manage the database, you don't manage the infrastructure. Amazon just recently, I think either like a month or two ago, launched instances that have compute and storage separated. Google already had it. And also we use like nested tables and jagged rows, which means that your rows of the tables don't have to correspond to the schema. You can have trailing empty spaces, which is a feature that BigQuery supports out of the box. And our analysts wanted to use it.
Thank you. Any other questions? Yes, one there.
Je pose la question en français aussi. En fait, j'avais une question stupide, c'était de savoir si c'était possible de le faire on-premise. Par exemple, si on a son propre data center, c'est-à-dire isoler des clouds propriétaires, notamment vis-à-vis des renforcements de la loi sur les questions médicales. Je comprends bien l'utilisation du Google Cloud. Là, vous venez de dire que la migration vers Amazon était possible et rapide. Moi, j'avais tendance à avoir un couplage fort avec Google Cloud. Donc, ma première question, c'était combien de temps ça mettrait d'étudier cette solution et de la mettre sur un autre fournisseur de cloud, par exemple Azure ou Amazon. Et la deuxième, c'était sur un système on-premise, sur de l'OpenStack dans un propre data center. Est-ce que ça serait possible pour maîtriser les données chez soi et pas à l'extérieur, chez la NSA et compagnie?
Oui. Également, est-ce que je réponds en anglais ou en français? En anglais. So the question was, if we have our own data center, is it possible to deploy a solution like this? And would it be possible to migrate this kind of setup into Azure and other clouds? I will start with other clouds. Yes, it is possible. Amazon with Redshift has a good offering of, I think it's data lake and other data management tools that some of them even correspond more to some of our needs, but Google was more flexible and more easy to integrate. To migrate all of that, well, it would take, I guess it would take maybe a week or two to spin up the infrastructure in a different cloud. because we already have the knowledge of AWS tools. If it was Azure, it would probably take a month or two because we have no idea how to use it. And then to migrate the data, we spoke about it with our Amazon team, and they said that there isn't an out-of-the-box solution to migrate data out of BigQuery into Redshift or S3 storage. So they would need to work with us, and that would probably take maybe also between 2-3 weeks. Things move pretty fast in the world of cloud. For on-prem, I will say I am not extremely familiar on how you can use different tools, but I would say if you really have the dedication to set up Hadoop and Hive correctly, and if you have the team of data engineers that are really good in this kind of setup, and they would know how to optimize the queries, and they would know how to optimize the data lookups and searches, then it is possible to have a flexible solution in our own data center as well. We just didn't have the capacity. We need to move really fast. We need to achieve all of this beautiful healthcare around the world, so we wanted something really fast.
Alors, je continue, juste. Après je laisse la main. Et combien vous êtes pour faire ça, du coup? Parce que ma question sur le on-premise, ça s'applique à une grande entreprise, effectivement. Mais vous êtes combien pour traiter ça?
The question is how many people we have to do this. So 2 infrastructure engineers, me and my colleague, maybe 5-6 data engineers that are really heavily impacted and work all the time on this, and they also know how to write some Terraform. We've taught them how to write Terraform, they've taught us how to deal with data. So, and people that come and go, but mostly, I would say 2 people that are on infra side and 5-6 people on data side. All of that given that we have pipelines, automation, Terraform, all of that. And we have about maybe 40, 50, 60 analysts that are actively using the data.
Thank you. Was there another question somewhere?
I thought there was one, yeah.
Joseph. Yeah, let's go.
Ouais, j'ai plein de questions.
Magnifique.
Un enjeu que tu dois avoir, c'est quel type de SLA tu définis vis-à-vis des data analysts ou des data scientists, c'est-à-dire en combien de temps tu es en capacité à leur mettre à disposition un nouveau dataset ou à mettre la sécurité qui va bien sur le dataset. Est-ce que tu as défini des engagements en termes de SLA avec eux? Est-ce que tu as défini une sorte de shared responsibility model avec eux? Enfin, comment vous avez essayé de contractualiser tout ça?
Question was, how did we define the data access models and the security around who accesses what and how fast we can give a new data set to the researchers? So we worked with the data teams, with data engineers and analysts, to define groups of people that will have access to a specific level of privilege. So we have insights analysts and researchers that have read access on data. And we give them, we have discussed that we have trust that they know what they're doing because they have had training. And that was decided between the leadership and the technical leads of those teams who confirmed that these people have had training. They've had medical training required by the National Health Service. They have had all of the criminal checks done. So legally, they can access the data. Then we've defined a group of people, and all of this was like a whiteboard discussion with key people from different teams. We thought that there will need to be a group of people that have elevated access. We call them data champions. They have access to prod, to logging, monitoring, storage, Cloud Composer, and they will also be able to debug the pipelines if needed. They develop them in dev. So that's there they have a lot of access, but that's dev, there's no sensitive data in there. And then we also said we need a debugger access that has access to read logs and to read monitoring data, so that a wider variety of people can go and debug certain situations if they happen, so that the load isn't on us or data engineers in general. To the question about how long it takes to create a new data set, I wouldn't be able to answer that. That's completely managed by the data engineers, but I would guess depending on how complex the query is.
Okay, and we've finished the time for the questions, unless there's one quick last question. No. Okay, Natalia, thank you very, very, very much.
Thank you very much. Merci beaucoup.
And here's a Toblerone honor to thank
Chocolat.
you.